beautiful people, and welcome. In this video, we are practicing more factoring questions for preparation for our test. As always, if I make a mistake, that is okay. Just let me know where the mistake occurs so that way we all can learn from my mistakes. Let's jump into question number one. In question number one, we have a trinomial. That means we have three terms. Step number one is always to see if we have a GCF. Now, GCF stands for the greatest common factor, meaning is there anything that all terms have that we can remove? In question number one, I have a squared, a, and 27. So I have an a here in the center term, but I don't have an a in the third term. I have a 12 here and a 27, but I don't have any numerics here on a. Therefore, there is no GCF. Now, step number two is asking us, hey, is there an a value? Is there an a here? Not this variable, but is there a number that's a leading coefficient here? And is that number 1 or not 1? If there is no number, that number happens to be 1 because it's kind of like invisible. Mathematicians are lazy, so we're too lazy to write 1 there. So this is 1. And so in this case, we do have a leading coefficient of 1. Is it a special factor? Now, special factors mean, is this a perfect square? Is the last term a perfect square? If it is, and we have special b term here, then we can factor it a different way. Since it isn't, we're going to use the guess and check method. Guess and check method says, hey, I'm going to have two things. We have a squared, so we're going to write an a and a here. I have two things that multiply to 27. However, we have them add up to 12. Now, you always want to take the symbol in front of the numbers. So in this case, we want them to multiply to a positive 27, and we want to add them up to a positive 12. So we're going to list our factors first for the multiplication. What are two things that when I multiply them, they give me 27? In my head, I'm thinking something that has to do with a 9. So 27 divided by 9 is 3. So we have 3 times 9 is 27. However, we also can do the negatives of this. So negative 3 times negative 9 is 27. I also have a negative 1 times negative 27. That equals 27. And I have a positive 1 times 27, positive, which equals to positive 27. Trying to think if there's any other factors. Don't believe so, so let's go ahead and move on to our secondary step, which here is to add up to 12. So we are taking these numbers here. So we're taking 3 plus 9, negative 3, negative 9, all of these factors, and now I'm going to add them together to check if they add up to 12. So 3 plus 9, 3, 9, 10, 11, 12, that does work. Negative 3 times, plus negative 9, that gives me a negative 12. Negative 1 plus a negative 27, that gives me a negative 28. 1 plus 27 gives me positive 28. So here we are checking which one does give us a positive 12, and it is 3 and 9. So those are our factors. Now the rest of them, we don't care about them. So that means 3 and 9, we don't care about these. Only 3 and 9 do we care about. And so what happens with this 3 and 9, we're going to write them here, 3, 9, and for our symbols, you're looking at the symbol of the number that you're multiplying. In case 3 is positive, 9 is positive, and that is our answer. These are our factors for the given trinomial. Let's do this one once more. This one's not in standard form, so let's rewrite it in standard form. So we got y squared plus 14y plus 45. Once it is in standard form, is there a GCF? I have a y, no y. I have a 14, 45, and nothing, so that means there's no GCF. So let's go ahead and list out our factors of 45. First one that comes to mind, 45 is 9 times 5. 9 times 5 is 45. We have negative 9 times negative 5. And I'm thinking it's one of these two. So this is multiply to 45, and we're going to add to positive 14. And again, this is positive 45. So I'm thinking 9 plus 5, because 9 plus 5 is 14. So the more you do this, you guys, the less factors you have to actually write out because you're going to be able to see them. So our two factors are 9 and 5. We're going to write our two parentheses. We have a y instead of an a here, so I'm going to write y and y here. 9 is a positive, 5 is a positive, and therefore we have our two factors. Moving on to number 3. Number 3, I am noticing big numbers. I'm noticing very big numbers. But I'm also noticing immediately that I have a 16 and I have a 49. Those are perfect squares. I have a x squared and I have a y squared. Those are also perfect squares. So in my brain, I'm thinking maybe this is the sum of squares, meaning I have a square of a sum. I'm going to have one bubble that's going to be squared. Maybe, but we have to double check. So I'm going to rewrite this as a perfect square. I have a 4 squared, x squared. Here I have 49, which is 7 squared, and then I have a y squared, so y squared. I'm going to combine the two bubbles, so I have 4x squared, and I have a 7y squared. And then in the middle, this is where we need to check. If it works, then therefore we have the square of a sum. So here's our check. 2 times A times B. This is our A bubble. This is our B bubble. So 2 times 4x times 7y. 2 times 4 is 8. So I have 8x times 7y. 8 times 7 is in fact 56. X and y, so this is 56. Oh, you guys can't see that, I apologize. 56xy, which does match up to this middle term here. That means that I can jump into factoring this as 4x, here's my A, plus 7y, here's my B, and then I get to square it, which is exactly the same thing as saying 4x plus 7y and 4x plus 7y. But this one is more condensed, so we do the more condensed one. So which one is your answer for this question? It would be this one here for your answer. All right, let's go ahead and move on. Just a few more questions. This one here is again is a trinomial, 3 terms. I am noticing I have a 2, 12, and 8. So that means I have a GCF. I'm going to pull out a 2, which means what is left over? 2 times what is 2x squared? So I'm going to have x squared left over. 2 times what is 12? That is a 6x left over. And then 2 times what is negative 8? I have a negative 4 here. So once I'm done here, I'm noticing that I have no more leading coefficients. So this is 1. So now I'm going to factor the things inside only. The GCF, that too can stay outside of the bubble. So I want to multiply to a negative 4, and I want to add to a positive 6. All right, so let's double check and see if we can factor this out. Multiplying to 4, I have 2 times 2, 2 negative 2. Oh, we want them negative, so one of them has to be negative. Then I have 1 times 4. Then I have, oh, one of them has to be negative. 4 times negative 1. And I think that's it. So let's see which one gives me a 6. And I'm already having severe anxiety because I don't think there's anyone that does add up to a positive 6. And that's okay. And I'll show you guys what to do if you have something like this. So 2 plus negative 2, that is 0. This is 0. This is 3. And this is 3. So definitely not positive 6. So we don't have two factors that multiply to a negative 4 and add up to a negative 6. So if that's the case, we call this prime. meaning not factorable. And so what's your answer? Your answer would be 2 times x squared plus 6x minus 4. That would be your answer because this right here cannot be factorable. Moving on to the next one. Oh, I see a 4. Anytime I see 4 or 9, I always get excited because I'm thinking squares. So 4 is 2 squared. X to the 4th power can be written as 2 squared squared. And I have something very similar here. I have 4 squared, which is 2 squared. But this time I have x squared, which is x squared. Combine the bubbles. So I have 2x squared squared minus 2x squared. So now we have a plus b, a minus b as our factors. So I have 2x squared plus 2x times 2x squared minus 2x. Here is our answer. And for the very last one, let's take a look at what we have. 6, 54, and 6. So I'm thinking GCF because I see 2 6's, so I have to check if 54 has a 6 in it. 54 divided by 6 is 9, so I can pull out a 6. However, I'm also noticing I have an m, and m. There should be an m squared here, I'm assuming. So let's add one here. So let's pull out one m. What's left over? Left over is m squared. Left over here is a positive 9m, and left over here is a negative 1. Remember, if you take out the entire term, if you factor out the entire term as a GCF, you have to put in a placeholder, something to keep its spot. In this case, it's a 1, and it is a negative here, so it has to be a negative here as well. All right, so let's go ahead and try to factor this one. Hopefully, it'll give us more luck than example 4. So we want to multiply to a negative 1. And it might not work because I'm already laughing inside my head. Multiply to negative 1, but I want to add to a positive 9. Like, how's that going to happen? Let's check. Because the only two things I can do for negative 1 is 1 times negative 1, negative 1 times 1. That's equal to negative 1. But when I add them, that's going to give me 0. And when I add this one, that's going to give me 0. So this, once again, is prime, and that's okay. So our final answer will be 6m times m squared plus 9m minus 1. And our final answer is just that as our factors. All right, beautiful people, thank you so much for watching this video, and I will see you in the next one. Bye!